not your human parabola? What's the difference?
When it's positive, it's pointing to you. And it's negative, it's the opposite.
So nothing new there. That's called a vertical reflection. And so while we're doing this, here's applying it to all of our other great functions that we've talked about. That's when the negative is out front, outside of the brackets. It's called a reflection in the x-axis. And that's in a vertical direction. So top goes to bottom, bottom goes to top. How do we graph it? First, for the wordy people, we change the sign of all y coordinates. Change the sign of all y coordinates. I'm going to show you something called mapping, which at the beginning is going to look really weird because you haven't seen it before. All it is taking what I just wrote in words and putting it into math symbols. So the same thing starts with x, y, and then a single arrow, which means goes to. And then we just say what happens to the point. So x's stay the same because this is a vertical reflection. It's not going to change the x. Y goes to negative y. So that's called mapping. It's saying the exact same thing as above, just without the words. X, y goes to x minus y. Okay, so let's start with a cubic as an example. So draw me the base graph of a cubic. Doesn't need to be exact, just give me the general shape. What does the general shape of a cubic look like? Okay, so it doesn't need to be exact, just give me the general shape of the cubic. Okay, so it should look something like that. Okay, so vertical reflection means the top is going to go to the bottom is going to go to the top. So it'll start on the left-hand side and then go down. So there's what a vertical reflection looks like with something other than a parabola. So bottom goes to top, top goes to bottom. What we didn't talk about last year was horizontal reflections. Oh, ooh. That's when the negative is inside the brackets. So let's just look at that. Vertical is outside brackets. Horizontal is inside brackets. Does that sound familiar? That's a reflection in the y-axis, and that's in a horizontal direction. So instead of going up and down, we're going to go side to side. How do you think we sketch it? You got it. Change the signs of all x coordinates. And talking about the mapping, which again is just notation for what you just wrote. It says that xy is going to negative x, comma, y. Grabbing my red pen, going to the top of the page. It might be helpful if you think about vertical, that says VER, although it looks like a K, is always going to affect y coordinates, and horizontal things are always going to affect y. That's totally just backwards. Forget that I just wrote that. Vertical affects y and horizontal affects x. Let's go back to this. You might want to write down that vertical affects y and horizontal affects x. Okay, whether it's a translation or a reflection or anything else we're coming to this unit. Again, so let's do a square root base graph, see what that one looks like. So again, just draw me the general shape of a square root graph. Doesn't have to be to scale. Tell me what it looks like. Describe it to me. So if I'd never seen it, tell me how to draw it. A swoop going to the right? I like that. I think you're thinking parabola. So instead of flipping up and down like the last one, this is going to flip side to side. So left goes to right, right goes to left. So a horizontal reflection, our swoopy is going to go in the other direction. Who has good logic skills? Can figure out why didn't I use a parabola for this example? Okay, so if you take a parabola and you flip side to side, what happens? It doesn't change. Why didn't I use the cubic? So you even have a picture here.
Oh, it looks exactly the same as you did the Y.
So if we were to take this cubic and I were to flip it side to side, it looks exactly like the vertical reflection. So cubics look the same no matter which way you flip them. So that's why I went to square root. Okay, so let's look at some actual questions. Just like what we did Friday, we're going to write down new equations after transformations. We're going to describe transformations, then we're actually going to draw them. Only when it says. So now you are on domain and range duty. So number one. They're telling you this graph was reflected over the y-axis. And we want to write the new equation. It's interesting because the mathematicians of the world cannot decide whether you reflect over a line, in a line, onto a line. Nobody knows. To me, it sounds over, sounds correct, but then they say, well, in a mirror, you're reflected into a mirror. So sometimes they'll say over the y-axis, sometimes they'll say into the y-axis, sometimes they'll say on. No one can decide. Okay, if it's over the y-axis, is that vertical or is that horizontal? So picture the y-axis, and if we're going over it, are we going side to side or are we going vertical? Okay, so I want you to show me the back of your hand. Let's practice the two reflections. A vertical, your thumb is now going to point down. So show me a vertical reflection of your hand. Okay, so do a couple of those. There's vertical. Okay, shake it up. Show me back of your hand. A horizontal reflection is going to go to the side. So the thumb is still pointing up, but we've flipped it horizontally. Okay, so there's for the tactile people. Let's do it again. Show me the back. Do we vertical reflection? Okay, points down. Okay, so thumb points direction. Back of the hand. Horizontal, thumb doesn't change direction. We're just moving from side to side. So if we go over the y-axis, is that horizontal or is that vertical? That is horizontal. So that's going to give us an indication right away of where we need to put this. What is a reflection? It's a negative. It's actually a multiplication by -1, but it's just the negative. So does the negative need to go inside the brackets or outside the brackets? Inside. So I'm going to keep the y. I'm going to keep the square root, and I'm going to keep that -3 that happened to be on the end. Now keep in mind, we talked Friday, is sometimes we get lazy with these brackets that are really under the square root. Really, the question is asking, does the negative go in front of the square root or under the square root? Where are horizontal things? Are they in front or are they under? Under. So there is a horizontal reflection. If the question had said reflected over the x-axis, where would we have put the negative? Outside in front. Okay, so that's the difference with a square root. Again, there's brackets, but we kind of get lazy drawing them. Okay, number 2, we just want to practice describing. So they've told us base graph is the absolute value. We want to know what's going on here. Negative tells us right away that it's a reflection. Where the negative is tells us if it's horizontal or vertical. Is it outside the brackets or inside the brackets? So that is a vertical reflection. Remember, that's just naming, that's not describing. So describing, we have to add either in words, or we tend to use the mapping because it's not as many words. XY is going to go to, well, vertical affects the, so X stays the same, Y becomes negative. So vertical affects the Y's. Now we've got this plus 3 in brackets. The fact it's in brackets means that it's horizontal. It's an adding, so that means it's a translation. And then we need to finish off the description by telling us how to move it. It's going to be 3 units to the left. Now there actually is mapping for translations. I tend not to use it because the arrow works better in my brain, but if you like the mapping, we would say xy goes to x minus 3y. So that's the same as saying 3 units to the left. Okay, so you can use the mapping, you can use the arrow, whatever works better for you. Okay, so just to repeat, describing means we name and we give the position of it. So it's not just enough to say VR and HT, we need to go further and explain it. Okie dokie, look at this good stuff. Sketch y equals 2x plus 3 squared minus 4, then sketch f negative x. State the domain and range for each graph. Okay, what kind of graph is this? It's parabola, and how many units did we spend on parabolas last year? A lot of them. So we've already done how to graph these, we're just going to review. We need 3 pieces of information to graph a parabola. Any guesses what those are? We need the vertex. We need the width. And we need the direction. How do we get the vertex out of this equation? So take the number of brackets, change the sign. And then take the number outside, leave it alone. Those actually were translations. We just do it all in one step. So this we know moved 3 units to the left, 4 units down. Direction, up or down, and how do we know? Okay, up and down, so fight it out. Up, up, why? Because we just talked about reflections and there's no negative, so it's going up. What does the 2 do? So last year we talked about the standard width, which is 135 dot, dot, dot. And what do we do with the 2? Times 2, so that gives us a width of? Okay, so starting with the vertex, negative 3, negative 4. Next we use the width, so we're going to count over 1 up 2 on each side. And then over 1 up 6 on each side. And if we had the room, we'd go over 1 up 10, which we don't have the room. And so there's our parabola. Okay, sketch f negative x. Inside brackets or outside brackets? Inside, so that tells us it's a horizontal. Something, something. The negative tells us it's a horizontal reflection. Mapping says that xy goes to. So what is affected by horizontal movements? Negative xy. I'm going to show you 2 different ways to do this question. You can pick whichever way you like better. The first is for non-visual people. What I'm going to do is mark down these 5 coordinates in order left to right. So the very left coordinate is negative 5, 4. The next coordinate is at 4, negative 2. The vertex is at negative 3, negative 4. The next coordinate is at negative 2, negative 2. And the last coordinate is at 1, 4. Now I'm going to do is exactly what the mapping told me to do. And the mapping says we're going to add a negative or multiply a negative to the x's, so it means we're going to change all the x coordinates and we're going to leave the y's exactly as they are, no touchy. So mapping says that negative 5, 4 goes to 5, 4. Okay, change the x, didn't touch the y. 4, 2 goes to, which I think should have been negative 4 now that I look at it. How about negative 4? 4, 2. Nope, didn't change the y. Don't touch. Was it at negative 2? It was at negative 2. Why did I earlier? -3, -4. 3, -4. -2, -2. And this also should have been negative. -1, 4. And if you use the mapping and you like this way, now you can just plot those 5 points. Okay, so go ahead and do that if you like this way. If you're not into the points and you're really visual, you can probably do it just from the graph. You have to have strong visual skills, and all I'm going to do is use the same points left to right, and I'm looking at the x value. Right now I am at -5. If I flip it horizontally, what's going to happen to -5? So I'm not going to move this up or down, I'm just going to come way over here and put it at 5. Okay, so the 4 didn't change. All I did was flip that point over the y-axis. The next point right now is -4, -2. If I flip it over, it's going to go to -4 is going to become +4. Okay? Again, I didn't move it up or down. It's still on the same y value. -3, -4, if I flip over, is going to become 3, -4. -2, -2 is going to become 2, -2. And -1, 4 is going to become +1, 4. So if you're strong visually and you can just see it, you don't need to do this. If you're struggling with the visual, there's nothing wrong with doing the points and then plotting the points. So 2 different ways, you can pick and choose whichever way you like better. The last thing we do with any of these questions is we stop and we double check and we say, did I do what I said I was going to do? Did I flip this horizontally? Can I see that I took it and flipped it over side to side? There you go. There's your first reflection. Domain and range. Okay, so for the parabola first. And don't forget, there's 2 ways. You pick and choose whichever one you want, but don't mix and match. Arrow on the left, arrow on the right means? Yes, and in terms of domain means? -infinity to infinity, or XER, whichever one you like better. Range, we have to look down. What's the lowest point on the graph? And the highest point? If we want to match the other notation, how do I say all the points from -4 to infinity? Now we did a horizontal transformation. So what is going to change the domain and range, or range? Which one's going to change? The domain's going to change because the range, we didn't touch the y values. So we have a freebie here, we can just copy the range, whichever one you like better. And then this one, because of the arrows, really it's not going to change either. So in this one, they happen to both be the same. Remember, you can pick which one you like better, but you can't mix and match. So if you start with the first one for domain, you have to use the second or first one for range, vice versa. So just repeating all of that. If you like to do the points and then just plot the new points, do that. If you're visual and can just see it, don't feel you have to do this. It's completely up to you. Look at this funky graph. Oh my God, what are you? You'll actually meet him next year, and he's called a quartic. Quartic. So I'm just going to mark some points so we can see what's going on. I'm going to mark this max here, which looks to be at 2, 2. I'm going to mark the 2 mins, which kind of seem to be -2.5, -1. Yeah, you're right, because that's -1, so a half. It's definitely -1, though. And this one, ooh, I don't even know. That's in the middle. I'm not going to care about it. And I'm going to mark the x-intercepts, because those are always important points. And I'm going to show you another way to do reflections, but you need a ruler, so if you don't have one, grab one. So I showed you how to do it visually. I showed you how to do it with points. This is just a different way that you might like better. We need to note this thing is going vertically, and sometimes it helps to put the arrow showing top to bottom so that you remind you're doing a vertical flip, not a side-to-side flip. And we're going to red pen because this is going to be our last graph. And first thing I'm going to do is remark all the x-intercepts. Those are really important points when we're doing vertical reflections. Who can tell me why? Because they're not going to change, right? What's the y-coordinate of any of those 4 points? 0. And if I change the sign of 0, what's going to happen? It's still the same. So in terms of vertical reflections, the x-intercepts are always really important. Now I'm going to go to that min, and I'm going to put my ruler vertically through the min. And sometimes what that does is help you not to move it side to side. What I just want to do is flip this up. So if it's at -1 and I change the sign, where is it going to go? +1. And by using the ruler, what you're not doing is moving it side to side. You're just doing that vertical switch there. So sometimes that's really helpful. I'm going to do the same thing at the max. Right now, the y-coordinate is about 0.5. If I change the sign, it's going to go to -0.5. And again, by using the ruler, what it does is we don't move it side to side. We're just moving it up to down. Same thing with the min here. Okay, it's at -1. If I want to flip it over, it's going to become +1. And so we know the graph has to come from the bottom, go through this max, go through the origin, through the min, through the y-intercept, up again, and back down. So I've now shown you how to do it visually, or with points, or with the ruler trick, whichever one works better for you. If this had been horizontal, instead of putting the ruler vertical, we would have put it horizontal. So the ruler is going to match the way that your reflection is going to go. Questions so far? Show me your thumb. I get this. Awesome. Let's plan for the rest of the 2 classes is just some time to work, because I know I kind of robbed you on that on Friday. So grab the workbook. It is page 183. I have not marked this, but I will do it right away. Do you feel like working alone? Do you feel like working with someone you pick? Do you feel like putting you into groups? Alone? Antisocial? Okay. So when we come back after lunch, we're going to do a few old exam questions for practice, and then you'll have the rest of that period just to work. Okay, so lots of time to get through this. What?
This is page 183.
Yeah, because remember we're a day behind.
Oh, right.
What do you need change for?
For the starting period.
No, but from what kind of bill?
Oh, no, I have like a...
Oh, you have a toonie and I owe you a loony. Yes, I do. Just make sure you take your name off the board. Ooh, it's chilly. Were you outside? Oh, it's really cold. 183. But remember, we're a day behind because we took a pause day. Oh, perfect. Perfect. Take your name off the board. 4. Yes. Thank you. Take your name off the board. Can you just take a picture of somebody else's workbook and then just work on your phone? There's change there. Perfect. Take your name off the boards, I don't forget. Ichang? Mm-hmm.